as we move forward from our lesson 7.3, where we were learning how to combine functions with addition, subtraction, multiplication, division, and also composite functions. So as we combined all of them, whether it was an f of x plus a g of x or some sort of combination, what we got with all of that was some new function. And so as we either start with our original function or our new function, we need to be able to look at our square root and our cube root or these nth root functions and know how do we graph them, right? Because the whole reason that we graph in the first place is to find those real solutions. Remember, we talked about real solutions were places where the graph crosses the x-axis. It was known as the zeros. It was known as your x-intercepts. They were known as the roots, which then again, we're working with root functions. They were called the roots. So these are the places where it's crossing the x-intercept, and those are giving us values, because if we're finding an answer for x, then when y equals 0, x is what? And that's the place where it crosses. So again, whether we have a numerical equation that we're working with, or if we actually have a graph, we can still find those answers for x. That's the end goal, trying to find an answer for x. So in the last ones, we learned how to work with all of our roots and how to deal with our functions and combine. Now we're going to figure out how do we actually graph them? How do we put those numbers into a picture on a paper? Okay, and for the case of this video, I haven't done 7.4 yet. I will do a video on that one after this because I want to go right in line for my mental thought of that. So we know that, let's look at this one. We know that when we graphed a quadratic, all quadratics are parabolas. And we know that for cubic functions, they were S-curves. So they're going to start on one end and they go up. Because a quadratic has a root, has an index of an even number, which means when we learned end direction, that our end directions were the same when it was even. And a cubic has the root of 3. And we learned that for our cubic functions, we had x cubed, and this one quadratic x squared. In the same way, whenever it's an odd number, they were in opposite directions. So those two things are not going away. We get to use them the same. So just as a quadratic, when it had an even term, was a parabola, where they went in the same direction, a square root, because it has an even index, will end in the same direction. And just as a cubic function, where it had an odd exponent and they ended in opposite directions, when we have an index that's an odd number, it will also end in opposite directions. Okay. As we learned about inverses from 7.4, inverses are across the transformation line of y equals x or x equals y. So it's going to be that diagonal line. And so when we look at those, we are changing from x squared quadratics to square roots. We're just going back and forth between them. So one thing that's important to notice, that as we talked about the word function in 7.3, we were calling them functions and deciding if it was still a function or not. When we have a function, it means it has to pass that vertical line test. So parabolas are functions because they pass that vertical line test. We can cross it anywhere. However, when we do the inverse of them and they become square roots, because that's the opposite. Remember, multiplication has division, addition has subtraction, exponents have roots. They are the opposite. So often, whenever we talked about multiplication and division for inverses, I've got addition on one side, subtraction on the other side. We're looking at a linear term of one's going one direction, the other's going the other direction. For multiplication and division, we've got multiplication and division undoes it. So again, we're kind of linear going back and forth. But when we are going with roots, that line of reflection is this y equals x. So it shifts it differently, which we have seen with the inverses. And so as we are looking at it, our parabola is no longer up and down. It's no longer a vertical parabola. It is now a horizontal parabola. And this horizontal parabola does not pass the vertical line test. We have hit twice on that. So while the original function, our quadratic, is a function, when it is a root, a square root, specifically a root with a 2 or an even number, that means they end in the same direction, it is not a function for those. Okay? And so as we had a cubics typically, whoops, not like that. Cubics typically look like this, like our S-curve around a point of reflection, which is, I still talk about it kind of like the vertex, as we were used to vertexes on quadratics. So again, when a cubic is inverse though, we have a very similar S-curve for that. And so it is still a function because you've got two ends that are going in opposite directions. So as long as you've got, it's coming from one way and it's going to another, and there's just a line in the middle, unless it's looping back on itself, it will always be a function because it's going to pass that vertical line test. All right. So how do we take what we know and look at an actual equation and put it on a graph? Well, we all love Desmos, so you can always graph it on Desmos to check. But let's consider, what do we have? Let's take everything that we know from before. And as we know, there's consistency in math. So let's see where we can still be consistent. So initially, when we had lines, right, linear equations, the most important thing about that was the slope, the rise over the run of the graph, and then maybe where it intersected. Like, did it intersect at the origin, or was it shifted to have a y-intercept at a different location? Okay. When we looked at parabolas and quadratics, we looked at our a value, which was the slope of those very first 2 points where it was coming from the vertex. And then we looked, was the vertex at the origin or was it shifted up and down? It could have been even shifted left or right or both, and maybe been in a completely different place. Okay, so all of those same things are going to apply. We're going to use some of the same terminology. I'm going to choose to use some of the same terminology, although it technically isn't a slope, but that way we can see the consistency of it and we know how to figure that out. Okay. So with square root graphs, we need to know that all square root graphs are part of a horizontal parabola. Okay, so we're no longer working with a quadratic where it was a vertical, a cup facing up or a cup facing down parabola. We are looking at horizontal parabolas. Okay, and when we are dealing with this, they are only going to be part of this. So then you kind of say, well, Miss Thomas, when I had maybe the square root of 4, I know that it's plus or minus 2. So why don't I have both values? Okay, because we need to step back and say that in this root, we are doing the square root of x. We are placing in x values underneath this root. And since our index is an even number, that means our x values can be positive or negative to get that. But whenever we come out, it can only be positive because we cannot place, like the answer on the outside would be positive or negative, but the X value that we place underneath here must be positive, okay? Because we can't do the square root of -4. We already knew that if we plug in -4, which would be over here, 1, 2, 3, 4. If I plugged in -4, then my answer involves an imaginary number with I. And so the X values that we are plugging in from our graph have to be positive X values. So we're only going to be working with positive X values here, okay? And as we work with the positive X values, we're only going to deal with one side of it. We're not going to deal with both of it. So as we have our answers, what determines whether we have the top part of the parabola or the bottom part of the parabola is our A value. And that's that slope portion. So as we start at our vertex, if A is positive, that means my slope has to be positive. So as we look at it, the portion from where I start, my slope has to be going up positive to that very next point. And if that next point, say, is right here, then that slope has to be positive if my A value is positive. Now, if I have my equation and I have a negative A value, again, I'm going to start back at my vertex, and my slope for that very first point has to be negative. And so that means I would be using only the negative portion of the parabola. So whenever we look at square root functions are going to be just an upper portion or just a lower portion of that parabolic graph. Okay, now if we look at cube root graphs are an inverse of a cubic equation. And we know a cubic equation is an S curve. And so a cube root is also an S curve. And it lies along the x-axis instead of curving around the y-axis like a cubic function does. So we're going to be curving along the x-axis and going infinity along the x values, whereas a regular cubic equation, if we had this, would curve like this, and it would go infinity, negative infinity to positive infinity along the y values. Okay, so we've just laid it down. We've gone a slightly different direction. We're laying it down. And again, what's important about it? The important thing, and this isn't the best curve here, is our A value. So when our A value is positive, from our point of reflection, or that little vertex point, to our next little sections on either side, it's going to be a positive slope. If our A value was negative, that means from our point of reflection to our curvature here, this section would be a negative slope, going down in a negative slope. So we're using all the same steps as before. And then just a reminder of why over here, whenever we have a square root, we're only on one side of the graph, and yet our S curves get to use both of them. Because remember, when we have an index that is an odd number index can have a negative value underneath, because we could have an odd number of bases that would multiply and get us negative, or it can have a positive. So I can plug in -9 as a value, and I can also plug in +9 as a value. We can use both sides of the graph for the x values for that graph. Okay, So let's get down to actually what the root forms look at. And I've pulled us back to chapter 5 with our quadratic forms so that we can once again look and say, it's not anything new. It's all of the same things. I've seen that before. Let's take a deep breath. Let's walk forward in what we already know and not be super confused by it, okay? So just like when we had quadratics, we had a special form called the vertex form. We knew that when we had a quadratic in the vertex form, that our vertex was found at HK. We talked about why H is the opposite sign than what is listed there, because Y and K are already on two separate sides of the equal sign. So the K value stays the same. X and H are on the same side of the equal sign. So we had to set X minus H equals to 0. And that means when we change sides, we change the sign of it. So our X value is the opposite sign of whatever is located there, right? So we knew that in a quadratic, we had HK was where our vertex was located. We knew that A was our slope from the vertex to that very first point. And we knew that because it was a squared term, that it had to be a parabola, and that was either facing up or facing down for it. So as I wrote, H was always our translation shift along the x-axis. It's how much our graph moved from the origin along the x-axis. And K, because it's that new part of the vertex, is our shift along our y-axis. So how much our vertex changes along our x-axis. So let's take what we already know about our quadratic vertex form and look at our radical square root form. So here's our quadratic, here's our radical. They're right next to each other. They look almost identical. There is still an A value. The A value is still what we like to call our slope term. There's an H value. There's a K value in the same location where X and H were tied up together in this one little unit. X and H are tied up together in this one unit, okay? H is the same. It's your shift of your vertex along the x-axis, exactly the same. K is your shift of that vertex along the y-axis, exactly the same. And where this exponent of 2 told us that it's a parabola, and it faces either up or down, which was controlled by our A. This root tells us that it's a parabola, but it's horizontal. So it's wrapping itself around the x-axis, where our exponent of 2 wrapped itself around the y-axis. So as we look at this brand new formula that we have, it's just the opposite of the quadratic formula that we already have, okay? So then let's translate that to cubes, okay? In the same thing, we had the vertex of a cubic equation was set in this form. So again, we have our A, which was our slope from that vertex to that first S-curve translation. So that kind of like bendy point of it to the very first one on both sides gave us our slope there. We had our H and our K values that were our turning point there, our little vertex, and it was HK, the same. K stays the same, H has the opposite sign. So just like that basic graph, we're going to look at the radical cube root form. It follows the same rules that our quadratic followed. Our A stays exactly the same. H is tied up with X. H was tied up with X here. H affects X of where this turning point vertex of where it sits on the graph. K affects it along the y-axis. And we knew that when it was cubed, our S-curve wrapped around the y-axis. Now we know that when we have the cube root, our S-curve wraps around the x-axis. So we've just laid it down on its side. So again, the basic graphs that we need to know for these two new forms are, like before we knew y equals x squared, we always knew that we could graph that exactly. That was our basic form. So the basic graph here is y equals the square root of x, where your a value is still 1, just like the a value here was 1, and it's just a square root. And that one is going to be your basic parabola along the x-axis. So the same for y equals x cubed. Our basic graph meant we were at the origin, we S-curved around the origin, and we were at 1, 1 on these. Our basic for our cube root is y is the cube root of x. Again, our a value is 1 for both. Our origin is 0, and so we're just going to S-curve around that x-axis. So it's important to know where we're starting so that we know how we can move through that, okay? So if we look at these two different equations, we're going to compare them and we're going to look at the graph next and see what that looks like. So if I'm comparing y equals negative 2x squared plus 3, let's think about that in our regular equation, right? So if I had x squared, y equals x squared, and I know that everything that I add to x gives me that h value, and everything on the outside were those k values, we're going to break this down. We know that it's a parabola. It's a squared term. It's a quadratic. We know that our slope is negative 2. So when we were answering our questions, it faces down. Our slope is negative 2. That means from the point of the vertex, we're going to go down 2 over 1 to find those very first 2 points. We see that nothing has been added to x, so we have no translation for h, no movement along the x-axis there, and that we have a positive 3 that's been out here, which is our k value. So it means our vertex has been moved along the axis to positive 3. So if we were to graph this, we could say, hey, my vertex is at 0, 3. I can put that little mark. I've got a negative, so it faces down. It's going to empty out, and it's going to go 2. So I'm going to go down 2 over 1 and place my very first 2 points. And I've got 3 points, and so I can graph that. Okay, so then let's compare that. We take the exact same graph. We're going to put everything in the same place, except we're going to use a square root now. So again, for this one, it's a square root. So what do we know? We know it's got to be a horizontal parabola first. Okay, we know that we are using the negative part of it. So we're not going, we know we're using the negative part, so we're not going to use all of it. We're only going to use this bottom part of it down here. We know that our first point is going to be a negative 2 slope, so I'm going to go down 2 and over 1, and that's going to be my first little point. And we know that our vertex needs to move. There's nothing added to 0, so we've got a 0 for our h, and we have a positive 3 for our y. So I'm going to take my basic graph of negative 2 square root of x, and I'm going to move it up. And I'd go 1, 2, 3, and then I would redraw it that way. So let's see what it looks like on the real ones. Okay, so our first one, we knew that it was a down-facing parabola. It's our red graph here. It's the whole thing. It has a slope of -2, so let's check it. Down 3, 2, 1, down 2, over 2. So I've got that negative slope of 2 there, and then we're going to reflect it on the other side. And instead of being at the origin, it has shifted the vertex to 0, 3. Okay, so then let's look at our other one that we were looking at, our root. We have a -2, so I know I'm using the negative portion. So I only use the negative part of the graph. From wherever I start at the vertex, I've got to go down 2, 2, 1, and over. So I've got my first point there for my slope. And that my vertex has also been shifted and is going to start right here at 0, 3. So this is how these two graphs look different when we've actually placed them on a coordinate plane. As we move forward, the best way to do this is to just examine different equations and walk through the practice of moving them on our coordinate plane. In this case, we have our first graph, our red graph, we'll call it number 1, is going to be our basic graph. We always want to start with our basic, just like when we were doing quadratics or when we were doing linears. We need to know what that basic line or that basic parabola or that basic S-curve is, and then we move it from there. So our basic one is going to be our red one. My A value is not shown, which means it's the number 1. So the very first point is going to be here at 1, 1. So I start at the vertex and I go to 1, 1. I know it's a root, meaning it's a parabola laying on its side, on the horizontal side. I know it's positive, and so I'm going to use only the positive part of it. So we start here at the origin. I'm going to curve up through my very first point, and it's going to go on to infinity. Now, how do I take that original and find this new graph? The square root of x plus 1 is -3. So the first thing that we need to look at is, what is our A value? Our A value is still 1. So wherever I start at the vertex, I'm going to go up 1 over 1. It's positive, so I'm only going to be using the top part of that parabolic graph. My vertex is found at HK. I know my K stays the same, so it stays -3, but my H has to be the opposite sign here. And here it's +1, so my H value is -1. So instead of my vertex starting at the origin at 0, 0, my vertex is now going to start at -1, -3. So I start down here for my vertex. I take my A value, which is +1, so I'm going to go up 1 over 1. And that's going to be at 0, -2. I'm going to use the upper positive portion, and I'm going to make a curve, and it is going to go to infinity on that one. Okay, so when we graph that root function, again, we start with our original basic graph and then answer these questions. And you can label them differently than I do, but I like to ask myself, what direction is it laying? Is it going to be positive, negative? Am I using the upper part? Am I using the lower part of it? What is that slope A value? This is going to give me that very first point that I need to know. And then, is my vertex at the origin or not? Or has it been shifted around? So let's describe this one. We know y equals the square root of x. It would be horizontal because it's a root function. My A value is positive, so I'm going to use the upper positive portion of it. I wrote down my A value is 1. And there's no shift, so it starts at the origin, which means that my very first point would be at 1, 1, up 1 over 1. So I already have the points that I need to be able to graph that curve. So let's look at another one. When we add things, we start at the beginning. What direction is it? It's a root function, so it's going to be that horizontal wrapped around the x-axis graph. My A value here is a 1. It's unseen 1, so it's going to be the upper portion, and positive. Again, my slope is 1, so I'm moving up 1 over 1 from wherever my vertex is. So let's look at it. Do we have any shift? Yes. I have something added to the X and something added on the outside. So here's my H, here's my K. We know our K stays the same. We know our H has to change the sign. So now my vertex is at -1, -3. And that means for my A value, when I go up 1 over 1, I'm going to go over 1 from here, which gives me a 0, and up 1 gives me a -2. So I've added 1 to both of those. And now I know that my first point is at 0, -2, and I can graph, go ahead and plot that graph there. Right? So let's look at this one and what we just worked out. This is what it looks like out in the graph. So did it work out that way? Yep, we have our red graph is our original. It starts at the origin. It goes up 1 over 1 for our very first point there, located at 1, 1. Here's our basic graph. When we translate it and we move it down 1, or back 1 for our X, and down 3, our new vertex is down here. But our slope is the same. We go up 1 over 1. So we are at 0, -2, which is exactly what we predicted where we would be. So I've got my vertex. I know my A value is positive. It's going to be the top portion of it. And we were able to graph it. And our Desmos graph came out exactly like our little sketch graph. So we're good to go on there. Let's look at these. When we have our basic y equals the square root of x, we want to make sure and have our A value in there. So I plotted our basic in a dotted line now. So I've got y is equal to -3 square root of x. That means I'm starting at the origin because I've got nothing added around it. It's a square root function, so I know it's horizontal. It's negative for my A value, so it's going to be the lower part of that graph. Remember, we've got an upper portion and we've got a lower portion of it. So I'm dealing with the lower portion of the graph. My slope for that very first point is -3. So I'm starting at the vertex. My slope is -3, so I'm going to go down 3 and over 1 to the point 1, -3. So if I were to take a line between this, that would have a slope, correct, of -3. That's basically what we're doing. In that case, that's my first point. I know it's negative, so I'm using the bottom portion. I've been able to graph my basic one. So let's compare that to the graph that they're asking us of, -3 square root of x -2 plus 1. Well, our -2 plus 1 give us our HK values. So I have shifted 2 in my X values, and I have shifted 1, +1, in my K values. So now my vertex isn't at the origin. My vertex is at 2, 1, up here. My slope has to stay the same, negative. So I'm going down 3, 1, 2, 3, over 1, that way. So I've got my slope of 3. It gives me my very first point here at 3, -2. I know I'm using the lower portion of the graph because I have this -3, and so it's negative. It's telling me I'm using the bottom portion. I can start at my vertex, go to my first point, and make my curve through on into infinity. Okay, let's look at a cubic. Again, our dotted line is our basic. We always want to start there. On this one, our basic is at the origin, nothing added to x, nothing added to y, but our slope curvature is 3. So what that means is when we start here at the origin, our next point in both directions have to have a slope of 3. So I'm going to go up 3 over 1. So that would be a slope of 3 here. And I'm also going to go back or down 3, back 1, so that between these 2 points, I also have a slope of 3. So we're able to make a straight line between our 2 first points here, and it's going to go straight through our little vertex section there. And that gives us our slope value. So that's how we make our S-curve. And an S-curve can only curve once between both of these points. So we can't come here and then curve back around a different direction. And it's important to know that when we have a cube root, our S-curve has to curve along this x-axis, right? So if we were to change our curve and make it curve a different direction, going through these points, maybe curving this direction through them, we can see that our endpoints are going along the y-axis. So we've curved the wrong way through our points. This is an x cubic equation, right? So we know it's an S-curve. It flows along the x-axis. We're using the whole graph. Our slope is 3. And now when we consider our new equation, we've had shift our h here and our k there. So we know that our h is the opposite sign, so it's moved -2. Our k is the same, so it's -1. So we're going to take this vertex point and we're going to move it back to down 1 right here to be our new vertex point. Now, our a value did not change, so we still have to have a slope of 3. So from our vertex point, I'm going to go 1, 2, 3 over 1. There would be my first point. I'm going to go down 2, 3, back 1. So again, I have a positive 3 slope from this point to our vertex, and then from our vertex to our next point. And my curvature has to be along the x-axis, so I have to go in infinity from the x, and I'm going to curve up, and I'm going to change directions at my vertex and curve back along to positive infinity along my x-axis. So we took our basic one, and we just moved the entire thing down and back. Okay, so that is how we look at roots. Let's look at a couple for your homework. For 15 through 18, it just says describe how to attain the graph of G from F. And so they have given, for example, number 15, G of X is equal to the square root of X plus 14. And they say F of X equals the square root of X. So when they're asking, how do we get G when we start here, we're looking at F of X and saying, this is our basic graph. We already know our A value is 1. We have nothing added. It's at the origin. Here's our base. Okay, so how do we go from our basic to this new G? Well, we would look at it and we would say that we've added something to the X, but we've not added anything out here. So my entire graph from what I've originally started with is just going to be moved backwards. Remember, if the 14 is positive, it's going to now be -14. I'm going to take my vertex and I'm going to move it back here to -14, and then that will be my graph. So all you need to write is shift the graph 14 units to the left, or move the vertex to -14, 0. You can write that in any way that you would like. Okay. For 19 through 21, it's asking you to match the graphs. So as we look at 19, let's see what we can deduce. It says 19 equals the square root of X minus 1. So the first thing we ask ourselves is this even at the origin? No, it's not. Where should it even start? There's nothing added to the X, but there is a -1 here. So if I have my basic graph, it's a square root and my A is positive. So here's my basic graph. It means I've added nothing. I'm shifting nowhere along the x-axis, but I am going down 1. So my graph here is going to start down lower. It's going to start at 0, -1, and then it's going to go up positive. Okay. So for 21, when we have y equals the square root of x plus 1 minus 1, we know that our basic graph starts at the origin. But now this graph starts at -1, -1. So I'm going to find -1, -1, and my graph has shifted here. It's still positive. It's still 1. It's going to go up that way. So use what you know about your graphs to be able to match up with the visual picture they have given you there. Okay, so for 22 through 30, it says graph the function and then state the domain and range. And I didn't cover that a lot in the homework because we had talked about that previously. I'm not so super worried that you're able to write that out, but if you were to describe it, make sure that you know what that means. Let's look at 22. 22 says y equals -5 square root of x. Okay, if I were to graph this, what would I do? Let's answer our questions. What direction does it lay? Well, this is a horizontal parabola because it's a square root. I have nothing added to my x and nothing added to my y, so it starts at the origin. Okay, my a value is -5, and since it's negative, I know I'm going to be using the lower portion of my parabola. Because it's 5, I know that for my slope, I've got to go down 5 and over 1. So I'm going to go 1, 2, 3, 4, 5 over 1. My very first point is going to be down here at 1, -5. I start at the origin, and I'm going to make my graph curve through there. Okay, so that's how our graph would look. And if I was going to ask what is the domain and the range, remember, our domain are our x values. So I'm using all positive x values. So they would be positive real numbers. Okay. When I'm looking at my range is the y values, and I'm using only negative y values. So I'm using negative real numbers for my range. Okay. When you have something like number 24, and it says y equals x to the 1/2 plus 1/4, that can trick us up because we now have a exponent, a rational exponent here. So just rewrite it. We know that x to the 1/2 means the square root of x plus 1/4. So again, we're going to take our basic graph. It's not going to move at all on the x-axis. It will move from the origin up 1/4 on the y-axis. And we're using the positive portion, +1. So you're going to have that upper portion of the graph. So don't get tricked up if it has a rational exponent for you. 31 through 39 are just cube root functions, so we're dealing with S curves. If it says it's cube root, you better have a full S on it. And it says the same thing, graph the function and state the domain and range. So for 32, we're looking at y equals -2 x to the 1/3. So they threw in this rational exponent. We could completely rewrite this. Y equals -2 cube root of x. Exact same function here. So what do we know? We know it's a cube root. So we know that it's going to lie along and wrap around this x-axis. That's the one we're looking at. We know that there's nothing added to the x and there's nothing out here. So our little vertex turning point is at the origin. And I know that my a value is -2. So from this point in my other 2 points, I have to have a -2 through the whole thing. So I'm going to kind of slightly sketch myself a line like x, like a -2 slope for that. Okay, so I've sketched myself a -2 slope, and that's going to help me put my little points on. So I'm going to go down 2 over 1 for my first one. That means I'm going to go up 2, back 1 for my next 2 points. And now I see that I have this -2 slope from my outer 2 points through my vertex turning point. Now, how do we graph this? This is something to remember. Our infinities are going in the direction of our x-axis because there's different ways that we could graph it. I could graph it coming down through these points and then curving around like that. It still has a -2 slope, but I am going in infinity along my y-axis for that one. And what we want to do is we need to go towards infinity along our x-axis because it is a cubed root, which means I need to come from x -infinity through my point, turn, go through my next point, and then go towards x +infinity. So I would graph it that way. And then it says state the domain and range. So again, our domain are all of our x values. How many x values on this graph are we using? We're using all of them, every single one, all real numbers, okay? And what y values for our range? What y values are we using? Well, this is actually going up into infinity and continuing to go, and we don't have any asymptotes to stop it, so it's actually going to use all our y values as well. Just forever and ever and ever, it will keep going down and keep going out for that. Let's see. There's another one. Let's look at 35, or let me look at 36. You're not assigned this one, but I want to show you what it looks like. 36 is y equals x plus 2/3 raised to the 1/3. So in this case, it can be a little difficult to see what you need to do. Let's change that to root form. This entire binomial is the cube root. So when we put it in this form, we can see that our 2/3 is simply our horizontal shift for our vertex. It's now at -2/3, and I didn't have any shift for y, 0. So when I'm dealing with my graph, I'm not starting at the origin. I'm starting at -2/3, 0. And I would still have my positive a value. And so I'm going to have my S-curve look like that along there, so that when I go from point to point, if I drew a line for them, I would have that +1 slope for that a value. And that is all for the homework, not a ton of homework problems for that. On the back side, you do have 51 through 53 as bonus problems, and it says write an equation for the function whose graph, and they give you a graph. So they've given you a graph, they've given you parts of the graph, and they've given you some points for it. So they give you a vertex and they give you some points on the graph. What you need to do is say, hey, I know my basic. This right here is half of a parabola. It's a horizontal parabola, so I know it's a root function. So I could start as y equals, I don't know what my a is. I know I've got an x in here. And then do I have an h and do I have a k? Well, it doesn't start at the origin. So yes, for this graph, you would have an h and a k let me just put those in. In this case, if this starts and this point is -2, -2, then I could plug in that my h value is +2, the opposite, and my k value is -2. If I'm given this other point, and I can look at my graph and say that point is -1, -1, the slope between my vertex and this next point is up 1 over 1. So my a value is 1. So right here, my a value is 1. We don't really even need to have the a value. So just by looking at the graph, I'm able to decide that y is equal to the square root of x plus 2 minus 2. So look at where your vertex is, plot your vertex or your turning point, and that will give you your h and k values for your equation. And then figure out your slope between the next two. If I had a cubic equation and I saw that my vertex was at the origin, I would know it's simply the cube root of x. I've added nothing. And all I need to find out is my a value. So I'm going to find my next point, and maybe this is at 1, 2, and this one is at -1, -2. And so I say, oh, I have a slope of 2 here. From the one point to the next point, I'm going up, so it's positive. That would be a +2. Y would equal 2 times the cube root of x. So that's a way that we can look at the graph and go backwards and just fill in those missing places that we know. So now you know how to graph cubic functions and square root functions.